Well, hi friends. My name is Jim. I am the director of Made New Makerspace, and I'm also the teacher of a program we're offering this fall called the Scientific Method. So what is the scientific method? Well, to put it briefly, it's a way that scientists, and really all of us, can understand and explore our world. The scientific method has 6 steps. It starts with asking a question, what if? Then you take it through research and a hypothesis that you test through an experiment. Finally, you put together an analysis that brings you to a conclusion. It's 6 steps, but what does that look like in the real world? Well, today, I'm going to show you. So, to my left, you can't see it super clearly on this camera, but if you look on the other side of my microphone here, I have a vacuum chamber. Today, I had a what if. What if I put a ping pong ball in the vacuum chamber? What will happen? And I don't know, but it's time to take that question, what if, from step 1 and do some research. Now, as I'm observing this ping pong ball, I can tell you that it is a sealed ball that has some air in it. It's not super full because it bings in a little bit, but it's got air in it and it is sealed and it's made out of plastic. The vacuum chamber obviously takes air out of it. Now, as part of my research, I wanted to simulate a ping pong ball in the vacuum chamber. So what I'm going to do is I'm going to take this Ziploc bag and I'm going to puff it out a little bit, and it doesn't need to be full of air because the ping pong ball isn't full of air, but this will be my ping pong ball analog. It's got a little bit of air in it. It's good enough. And I'm going to put this in my vacuum chamber. Now, what I want you to see is what happens when I turn this on. I'm going to take my handy camera here, and we're going to put this on top so you can actually look in the chamber and you can see what happens. There it is, and as soon as I turn on the vacuum chamber, it's going to start to rise. Now look at this, we are not even, wow, we're at past 15 inches of mercury, and that bag now looks super full. And that's just because there's no more air in that chamber. Oh, hello. All right, so at about 20, I'm gonna turn this off now, at about 20 inches of mercury, just a little less, the chamber was so deprived of air that the little bit of air that was in the bag erupted. Okay, that's a result. That is something that we can take and we can move into the hypothesis phase. So the first question, remember, we started with our question and then we went on to research. That first question was, what if I put a ping pong ball in this chamber? Now I'm going to let the air back in, and as that air comes in, you're going to hear a little whistling noise, but I want to show you what happened to that bag. This is part of our research. Once it gets up, the bag obviously deflated. Now at its strong point where it was sealed, it is still sealed. It actually, if you see here, there must have been a slight weakness in the bag where it erupted and the air came out the side of the bag. So my hole is here, not where you seal it. That's a very interesting result. So now as I'm looking at the ping pong ball, one of my next observations before I make my hypothesis is that there is a seam on this ball. And you can't see it super clearly here, unless maybe I get it super close, but there is a seam on that ball. Now, I'm going to make a hypothesis that when I put this ball in my vacuum chamber, it might pop, because I think it will pop. I'm not going to be wishy-washy. I'm going to say it will pop because this bag popped. But I don't think it's going to erupt along that seam where the two pieces of plastic come together. I think it's going to pop, and it's going to pop along somewhere on the weak spots on the plastic. Now, one ping pong ball would be a cool result if it pops. I'm going to drop that in there. But I think what would be really cool would be 150 ping pong balls. So let's drop that in. All right. Now we have some science on our hands. So here we go. We have 150 ping pong balls that we're going to pop in here now, all for the sake of science. Going to load this, close that up, and we're going to see what happens when I take 150 ping pong balls. Now, my hypothesis is that this is going to be like the world's worst popcorn experience. It's just going to go everywhere. But let's turn on the pump and see what happens. So the mercury's climbing again. And the way that they came up with this inches of mercury was they actually would take a container of mercury attached to more or less a straw, and then on the other end they would apply a vacuum. And as you pull more of a vacuum, and that vacuum gets stronger and stronger, the mercury will rise in that straw higher and higher. So when you get the equivalent, and I got to make sure it seats properly. There we go. So like right now it's coming up on 10 inches of mercury. That means that what we have is the equivalent of that straw moving, the mercury moving 10 inches up the straw. Now we're at 15. So at this point with the baggie, it was full and it was about to erupt. We're coming up on 20 inches of mercury now, and I'm still not seeing an eruption. This is an interesting result. We're past 20. I am very, very intrigued by this because I totally thought that by now we would have like ping pong popcorn. Not there yet, and we're at 25. So we can't get much more of a vacuum with this pump. A perfect vacuum is just past 29 inches of mercury, and at that point that's the highest you can get the mercury up the straw, and this gauge represents that. We're at about 27. We're at 28. When we get past 29, I'm going to stop the machine, because at that point it won't be able to get anything else out. And that's all she wrote. So, I don't know about you, but that doesn't look explodey to me. And you can see we're holding at 29 inches of mercury. And I'm going to get rid of that so you can just see there's no change whatsoever on the appearance side. And maybe, I'm going to back this up a little bit, maybe what we need to do instead is I need to agitate a little. Now, from how it sounds, those don't sound like a ping pong ball. Those actually sound like they're hard. They sound like a ping pong ball has a little bit of a softness to it. When you bounce it, you can hear kind of a soft ping. I'm not hearing that. I'm hearing a very hard ping against the side of the walls. Let's let the pressure out and let's see if we can figure out what's going on. So in our scientific method, one thing that you're going to see is that step 4, the experiment which we just ran, leads to your analysis and then your conclusion. Now, in science, it's not bad at all. If your analysis and your conclusion is something totally different, it's not bad at all. It's exciting because that means you're learning something new. And so as I look at these ping pong balls, they are no different from what they used to look like. Let me take this camera and I'm going to dig around here. Let me grab the desktop camera. Okay, so here we go. I'm digging around. As far as I can tell, those are exactly the same as they were before they came in here. And that is an interesting result. So how did we get there? What is our conclusion? So my analysis is that they have not changed. They didn't explode. They didn't explode anywhere, not on the weak spots, not on the seams. And so researching this, what I'm thinking is that when I look at my analog, I look at my bag that I use, this is a very thin, fragile material, and it has some weak spots in it. These ping pong balls are very thick, and again, they're not all the way full of air. I can compress them pretty easily. So my conclusion would be that no, in fact, when you put a ping pong ball or 150 ping pong balls in a vacuum, you don't get an explosion. What you get is a ping pong ball that is unchanged. Now, my next experiment could be to determine whether or not the pressure inside the ping pong ball is growing. I heard, remember at the end of that observation, that these sounded really hard against the walls. Like right now, you can hear they're kind of soft, but when they were in the chamber, it sounded like they were very hard. So I could tell that these balls were being put under pressure. And so that could lead to another set of experiments. But today, we don't need to do that because we have answered the conclusion of our original question. What happens if you put a ping pong ball in a vacuum? And the answer, not a thing at all. Which is a cool answer. That's okay. Thanks for watching. I am Jim, and this was A Minute with Made New.